Today topic is performance of transmission line. Performance of the transmission line, the most important consideration is voltage drop, line losses, and transmission efficiency. While studying the performance of transmission line, the transmission line voltage drop, line losses, efficiency of transmission is very important. So, this voltage drop, line losses, transmission of efficiency will be greatly influenced by transmission line parameters. What are the transmission line parameters? It is also called transmission line constant. R, L, C and shunt conductance. Resistance, inductance, capacitance and shunt conductance. Shunt conductance value, it is leakage over insulated. So the value of shunt conductance is very low. So it is almost neglected in power system. While remaining resistance, inductance, capacitance. Three parameters: resistance, inductance, capacitance. R, L, C. These parameters will be decide the performance of any transmission line. Okay. So while studying the performance of transmission line, the important terms most studied in the transmission line is the voltage regulation and transmission efficiency. Okay. While studying the performance of transmission line, these definition, these parameters: voltage regulation, and transmission efficiency. Transmission efficiency will play a very important role. Okay. What is voltage regulation? Voltage regulation, mathematically it is defined as percentage of voltage regulation is mathematically defined as Vs minus Vr by Vr into 100. So mathematically it can be defined as Vs minus Vr by Vr into 100. So when a transmission line it is carrying current, there is a voltage drop due to line resistance and inductance. This results, what happens? Receiving end voltage always less than sending end voltage. Receiving end voltage it is denoted by Vr. Sending end voltage it is denoted by Vs. So when a transmission line it is carrying current, there is a voltage drop. Compulsory there is a voltage drop due to resistance and inductance. These are the transmission line parameters R and L. Okay. Due to R and L in a line, always voltage drop is present. Okay. The result is voltage drop at receiving end. Due to this, receiving end voltage always less than the sending end voltage. So this is the difference of this voltage. It is represented as a percentage of regulation. It is called voltage regulation. So mathematically it will be written as Vs minus Vr by Vr into 100. Similarly, second term, transmission efficiency. Transmission efficiency, okay. The resistance is the important parameter. Resistance main causes power loss. Okay. Resistance is above the flow of power electrons. Okay. Above the flow of electrons means power loss. Resistance main purpose is power loss. Power loss is directly determines transmission efficiency. Efficiency will be directly affected. Resistance means it is a power loss in the transmission. Power loss means it will be greatly affected directly by transmission efficiency. Okay. So transmission efficiency it can be written as mathematically. Okay. Output by input into 100 or output by output plus losses into 100. Or in terms of transmission line, output means here receiving end power. Input is nothing but sending end power. So it can be written as receiving end power plus losses into 100. Power delivered by power sent out into 100. It can be written. Okay? So transmission efficiency, power delivered by power delivered plus line losses into 100. Okay na? So these two important terms must used in the studying of performance of transmission. Voltage regulation, transmission efficiency. Voltage regulation means difference of voltage from receiving end to sending end. Okay na? When a transmission line is carrying current, there is a voltage drop due to line resistance and inductance. The result is receiving end voltage always less than the sending end voltage. Whatever the difference of voltage, it is expressed as a percentage of transmission line. Okay? It is called voltage regulation. Transmission efficiency means receiving end power by sending end power, or power delivered plus losses into 100. So these two terms must be used in performance, studying of performance of transmission. So coming to classification of transmission line. Classification of transmission line. So they are classified according to their distance, according to their length, and according to their operating voltage. They are basically classified as three types. One is short transmission line, second one is medium transmission line, long transmission line. Okay. So how it is classified? According to their length, distance, according to their operating voltage, it is classified. Okay. So coming to short transmission line, their length up to 80 kilometers, range, 80 kilometers, and operating voltage less than 20 kilowatts are classified as short transmission line. Their operating voltage less than 20 kV, and their distance, length is up to 80 kilometers are categorized as short transmission line. Coming to medium transmission line, the length is increases from 80 kilometers to 250 kilometers, and their operating voltage 20 kV to 20 kilowatts to 100 kilowatts are classified medium transmission line. Their length is 80 kilometers to 250 kilometers. Operating voltage is between 20 kV to 100 kV are classified medium transmission line. Coming to long transmission line, their length is above 250 kilometers. Operating voltage above 100 kilowatts are classified as long transmission line. Okay? According to their length, according to their operating voltage, so transmission line can be classified three categories: short transmission line, medium transmission line, long transmission line. Coming to short transmission line, okay? Their length is 80 kilometers. Operating voltage is low, 20 kilowatts. So, due to insufficient length, due to insufficient operating voltage, here operating voltage is very low, 20 kV. Distance is low, comparatively low, 80 kilometers. Due to insufficient distance, insufficient voltage, here effect of charging current, line charging current is very low. Okay. Due to lower distance, due to lower operating voltage, the charging current is very low, capacitive charging current. So, while considering short transmission line, only resistance and inductance taken into consideration. Capacitance is neglected. Why neglected? Due to insufficient length, due to insufficient voltage, charging current is very low. Capacitive charging current is very low. In case of studying short transmission line, capacitance effect is neglected. So here short transmission line only resistance and inductance, and the RL series circuit, simple RL series circuit, only resistance and inductance taken into consideration. Coming to medium transmission line, length is increases. Length is increases. 80 kilometers to 50 kilometers. Operating voltage also 20 kilovolts to 100 kV. Here, due to sufficient distance, due to sufficient voltage, here length, okay na? Higher voltage, 100 kilovolts, okay na? Here capacitive charging current effect is taken into consideration, okay na? In case of medium transmission, effect of charging current is more. So effect of C, capacitor also taken into consideration, okay na? In medium transmission, both R, L and C are taken into consideration, okay na? So while studying the performance of medium transmission, so there are three methods are there. Medium transmission, analyzation of medium transmission, there are three basic methods are there. These are, one is end condenser method, second one is nominal P method, third one is nominal pi method, okay na? While studying the medium transmission, here three parameters, resistance, inductance, capacitance also taken into consideration. Here capacitance play very important role, okay na? So analyzation of medium transmission, there are three basic methods are there: end condenser method, nominal P method, nominal pi method. End condenser means capacitance, okay na? So in medium transmission line, capacitance play very important role. So the capacitance can be taken into consideration. How to analyze, okay na? Capacitance. Suppose first method, end condenser method. End means sending end side, receiving end side. End means receiving end side or load end side. So whatever the condenser, whatever the capacitance, we are concentrated capacitance. Capacitance can be connected at receiving end, or capacitance is taken into consideration. This capacitance can be connected at a receiving end side. It is called end condenser method. Okay na? Are you understanding? Medium transmission, effect of capacitance is play very important role. Whatever capacitance can be connected sending end side or receiving end side or middle side or both side, okay? Basically there are three methods. Capacitance is first method. Capacitance can be connected, concentrated at end side, receiving end side. That is called end condenser method. This is nominal P method. Whatever the capacitance is exactly connected at midpoint, sending end side, receiving end side. Capacitance can be connected exactly midpoint, so it is shaped like a T. It is shaped like a T. So this method is called P method. And third method, pi method. Pi means capacitance of each conductor. And capacitance can be taken. Capacitance be connected at sending end side. Capacitance connected can be receiving end side. Both sides. It is shaped like a pi. Symbol pi. So that is called nominal pi method. Okay? So analyzation of medium transmission line. This topic. Today actually this topic. Okay? Medium transmission line. Here capacitance play very important role. Capacitance means the total. Capacitance, it is concentrated or connected sending end side or receiving end side or middle side or both sides. So there are basically three methods. Suppose capacitance connected receiving end side, that is called end condenser method. Capacitance can be taken at exactly midpoint, it is called nominal P method. Capacitance connected both sides, sending end side, receiving end side. So it is shaped like a pi, symbol pi method. Okay? E model, pi model. So this is medium transmission.